Hello Internet, my name is Quentin and this is Blondihacks. This is the conclusion of our 4-part series on building this adorable little engine using only our lathe. I hope you've been following along because in this video we're going to get to see this engine run for the first time, and let me tell you, that never gets old. It's why model engineers are so obsessed with this hobby, because no matter how simple or how complex the engine, when you see that thing run, it's the best feeling ever. So let's go. Our engine is almost done. The main component left to do yet is the air fitting at the top, or steam fitting, or whatever type of other gas you might want to inject in there. Like I said, not judging. I'm going to use this piece of hex bar stock that I happen to have. It's very convenient for making plumbing fittings, but you can also make this out of round bar. You could use an offcut from the piston, for example. If you're new to model engineering, you may not have scraps of hex bar stock lying around. It's a little bit exotic. But if you're interested in model engineering, you should definitely accumulate this stuff in various standard sizes. It saves you a ton of time when making your own hardware, nuts and bolts and other things, banjo bolts, that sort of stuff, and also, of course, plumbing fittings, which you will make a lot of in this hobby. After facing off the end, as is tradition, I'll face the end of it down to a round diameter. This will be the threaded portion. Of course, if you're looking at the picture in the corner, you've noted that my CAD model does not show the hex profile on this. If you make this out of round bar, you can install it and remove it with smooth jaw parallel pliers, or even finger tight is actually good enough if you've got some sealant on the threads. This thing doesn't actually have to be all that tight. So once I've turned that down, I'll go ahead and put the threads on it, of course. I'm making this all in one setup just because it's convenient and there's no specific need for concentricity or anything here. So I'm doing some operations in a slightly tricky way just because it allows me to do all of this stuff in one setup. Once the threads are done, then I will make the hole down the center for the actual passage of the gas. A trick I've learned over the years in model engineering is when making threaded thin wall fittings like this, do the threads first and then drill them after, because the threading die puts quite a lot of force on the wall of that fitting, and it can distort or change the diameter of the hole if the hole is already there when you cut the threads. Fittings like this are quite quick to make because you don't really have to be very accurate. So for example, when setting the dimensions of the various sections, I'm just using a razor blade to find the edge of that shoulder, and I'll translate over from here. Not a lot of precision required. The great thing about owning a lathe is you will never ever have to buy another plumbing adapter if you don't want to. You can make pretty much any plumbing adapter you want in about 10 minutes. Do you want to attach that JIC hydraulic hose to a propane tank? You can with a lathe. Of course you shouldn't, but you can. In fact, they put left-hand threads on propane tanks specifically to prevent stupid people from connecting stupid things to them. But with a lathe, there's nothing standing in the way of your stupidity. I created the barb fitting at the other end with a grooving tool. This is a very large diameter barb relative to the rest of the fitting because it's designed for a very soft silicone hose that I'm going to be pushing over the end of this. That will work for compressed air or steam. And Yahtzee. I couldn't reach the top edge of that in the lathe because it was too close to the chuck for chamfering, and you always want chamfers on all sides of a hose barb so it doesn't cut into the hose. So this cone deburring tool actually does a nice job of that. And there we go, there's our little plumbing fitting. It's looking pretty nice. Those little fittings are satisfying to make because they're quick and easy. Now then, on to engine assembly. Let's get everything together with some oil. This is a basic hardware store 3-in-1 light oil. For a simple engine like this, honestly, anything that used to be dead dinosaurs is fine. People get really obsessed and religious about oil, but anything pretty much will work fine in most situations. For model engines, they really aren't that fussy. This is not a high demand application. Make sure to get oil on every moving surface, which on a wobbler is basically everything. This engine is assembled by putting the piston in the cylinder and then sliding the pivot into the frame because it's the longest thing, and then sliding the piston connecting rod over the crankshaft pin kind of at the last minute. It's a little bit fiddly, but you can kind of slide this whole assembly on there all at once. This method minimized the number of fasteners or other trickery needed. Again, trying to keep the part count low on this engine. Then we can get the spring adjuster on the back side. And then I'll adjust the tension on this as well until it feels like it's moving freely. When the engine is new, it's going to want a little more tension to run well, but as the engine runs in, as those surfaces bed together, it'll run better with less tension because it'll run freer and it doesn't need as much tension to keep that valve face sealed. That's the purpose of the spring, is to strike a balance between squeezing the valve face together and allowing the engine to pivot freely. I'm going to get my compressed air line on here. You test pretty much any model engine with compressed air. This is simple silicone tubing. Silicone tubing is fine up to about 20 psi. You really don't need full braided air line for most applications in model engineering. What you will need is a low pressure air setup for testing model engines. So in the lower left is my standard air compressor hose, which goes into this valve, this ball valve that acts as a volume control for the air. Then that feeds into this low pressure regulator. This regulates 0 to 20 psi. You can buy these in any hardware store. You'll need a pressure gauge. The one I have here is actually a tire pressure gauge for riding lawnmowers because they have very low tire pressure in them. So you can buy that at a garden center or a hardware store, auto parts store, those kinds of places. They all have one of a few standard threads on them so you can adapt them to the regulator. And then the other thing I have on here, which you do not need, is 2 different types of air dryer. These are on here just because I also use this setup for running my powder coating gun and my micro sandblaster, which both require extremely dry air. All right, moment of truth. I recommend generally starting about 10 psi. That's usually a good ballpark for any model engine on its first run. And you are going to have to give it a little spin to get started because this is a single cylinder engine, and single cylinder air engines or steam engines are not self-starting. You also need to know which way to spin up the engine. The traditional direction of rotation for steam engines is counterclockwise when looking at the flywheel. That's how I've designed this engine. For a wobbler, the direction it runs is set by the positions of the valves on the frame. If you swap the intake and exhaust valve, the engine will run clockwise instead. Okay, here we go. Turn on the air and give it a spin. Well, let's see what happens. Let's see if we've built a runner. Hey, look at that. It runs. Of course it runs. They always run. To quote Emma's Spare Room Machine Shop, it's a great thing about steam engines is they always run. They're very forgiving machines in that way. The very first steam engines had wooden pistons, so that tells you how forgiving they actually are. They always run, but everything above that in terms of build quality and sophistication is all about efficiency. This is different than internal combustion. Internal combustion engines are very difficult to get them to run, but once they run, they pretty much perform at very close to peak efficiency. Steam engines always run, but unless they're built extremely perfectly, they can be very inefficient. They can waste a lot of fuel and waste a lot of water. Then, of course, it's always fun to try and see how little pressure you can get it to run on. My personal benchmark is always 5 psi. If I can get an engine to run on that or less, I'm happy. For a brand new build like this, it'll need a little more pressure. This one's running on 6, which is quite good. Something more like 10 is pretty typical for a first build. But then as the engine runs in, all the parts bed in together, the seals get better, the bearings run a little freer, then it'll start to run on less and less pressure. There's an old saying in steam engines, they run at their very, very best right before they need a rebuild because everything's worn out. You can see me checking for how much it's leaking as well on that valve surface. It will definitely leak on that surface, especially when it's new, but the longer it runs, the more those surfaces will bed together and the better that surface will get. And as the engine runs in, you can also loosen the tension on that spring a little bit as well, because the seal will get naturally better and better and it doesn't need as much squeeze holding it together. But that engine is running very nicely. So that's pretty awesome. It's great to see an engine that you built run, and running on air is pretty fun. In the same way that if you like to drive, going to a track school and doing some track days in your car, it's pretty fun. You learn about the real physics involved, you find out how bad a driver you actually were, you get a lot better at it. It's pretty fun. And then one day, you try wheel-to-wheel racing. And it's like the difference between watching skydiving in a YouTube video and jumping out of an airplane yourself. It's in a completely different league as far as experience goes. And that's what running on steam is like. Steam is so much more fun. There's so much more going on. It's a much more sensory experience. Steam has way more energy in it than compressed air because most of the energy in a steam engine doesn't actually come from the expansion of the compressed gas. It comes from the thermal expansion of the steam. I also just want to show you that if you build this engine, you can indeed run it on steam if you'd like to. Of course, you will need a boiler. The one that I'm showing here, I do have a playlist on building this if you'd like. There are also some boiler kits out there that you can buy, and I think there's some companies that sell fully made boilers. Here you can see I've made a little adapter tube because that fitting is really too small for that larger clear tubing that I was using for the air, and steam is much more pernicious than air about having everything sealed properly. Steam will find every little crack in ways that compressed air will not. And you can also see that I've got simple zip ties holding that on. You don't actually need hose clamps. Up to about 20 psi of zip ties actually work fine if your hose is properly sized. And speaking of having no wrench flats on your fittings, I did not put wrench flats on that safety valve fitting, which was probably a mistake because I take it on and off a lot because I use it as the fill port on this boiler. One of my favorite things to do with 3D printing is custom funnels. I have a custom funnel printed for all of my boilers to make filling them super easy. I run distilled water in this boiler because it saves me having to worry about scale buildup or other issues that happen when you run tap water in boilers. It's a little more expensive, of course, but for a little boiler like this, it doesn't use very much water. And the funny thing about boilers is that they are so perfectly air and pressure tight that you literally cannot fill them unless you remember to open one of the other valves to let the air out as the water goes in. I often forget that, and I fill up the funnel, and I wonder why the water's just sitting there. And as I fill it, I remember that, oh yeah, this check valve dribbles quite a bit. It's very leaky. I need to do something about that. That's the feed water inlet port, which I won't be using for this little test run, so I'll just cap that off for now because the dribbling is going to annoy me. The water gauge blowdown valve also dribbles, as you'll see, but at least I've only got one dribble. Now for fuel, I'm firing this boiler on camping gas. These little containers are very handy. Camping gas is a mix of propane and butane. And it's handy because these containers are very low pressure, like less than 1 psi. I think they're 0.5 psi, which means you can feed them directly into a gas jet. The downside to them is that there's really not that much energy in this stuff. It's designed to heat up a can of beans. It's not designed to fire a pressure vessel. So you pretty quickly run out of oomph from your fire if you're trying to run a larger engine or an engine with a bunch of load on it, like running an electric generator, for example, even a model one. The gas jet goes into the burner. You got to set the depth just right. I have a line marked on it for this purpose because the position of the jet sets the air-fuel mixture of the burn. If it's too rich, then of course it'll burn very dirty. You make a lot of smoke and a lot of carbon dioxide and carbon monoxide. And if it's running too lean, the burner will actually consume the ceramic material, which is very bad. Important safety note, always have a carbon monoxide detector handy when running a model boiler. I've got one just out of frame there. I've got the garage door open as well. Never run these indoors. All right, let's kick the tires and light the fires, and away we go. This is kind of what you want to see. The fire is sort of little blue peaks. You can't really see the flame itself. It's kind of invisible in shop lights, but if it's mostly blue, then you're doing it right. And away we go. This boiler fires very quickly, actually. It's, I think, the best one I've built in that regard. In about a minute, the needle comes off the pin, and very quickly indeed, we're climbing our way up to 60 psi, which is the blow-off valve setting for this boiler. Because it's gas-fired, I only need one safety valve. If something goes wrong and the pressure is climbing, you can just shut the gas off and the pressure will stop climbing. Can't do that with solid fuel, so you need a lot more other safety mechanisms if you're wanting to burn wood or coal. Okay, here we go. When you first open the valve on a boiler in a fresh setup with a cold engine, there's going to be a bunch of water that hits the engine because all of the tubing and the engine itself are all cold. And because this simple little engine doesn't have drain valves on the cylinder, you're just going to have to kind of push the water through the cylinder. Just push it past the piston. But that doesn't take very long because a small engine like this heats up very quickly. And very soon you'll be able to see that it's getting real steam and it wants to run. Oh, almost. There it goes. Once you get the water out of the system and it starts running very nicely. Look at that. It's a choocher. Running a single acting wobbler with a ringless piston is definitely a front 3 rows will get wet situation. there is steam flying out of everywhere because this is not the kind of engine that's really very good at containing the steam. There's also, of course, steam leaking out of the valve face because it's not run in yet, and so yeah, everything's going to get wet. You're going to get covered in steam running this engine this way. They're not the best choice if you want to run on live steam, but they will run on live steam, which is why they're fun. If I get the angle just right, you can also see the exhaust jet coming out of the back of the frame, which is pretty cool. Also note that I am wearing gloves at all times when operating the engine on live steam. People think that those puffy clouds that you see are steam. No, that's water vapor. Live steam is an invisible superheated gas, and you will find it if you get anywhere near a jet of it that's leaking out of somewhere with a bare hand. It will scorch you very badly instantly. Don't mess around with it. Always wear gloves. Around now is when you'll find out if your piston clearance is correct. If the piston is too close fitting, it'll run extremely well on air, but if you try to run it on steam, it'll seize up after a couple of minutes because the piston will expand quicker than the cylinder and it'll seize up. The other fun thing about running these little engines is that when you're done for this session, you can shut the gas off and it'll still run for several minutes just on the residual pressure in the boiler. Like it'll run all the way down until the clock is reading 0. You have to depressurize the boiler some way or another, so might as well do it this way, which is fun. Well, there it is. Our little bar stock wobbler made entirely on the lathe, runs on air, runs on steam. It's a choocher. I really hope that you will give this engine a try on your lathe. I think it's a really fun early beginner project. Right after you've gone through my lathe skills playlist and learned some very basic fundamentals of using your lathe, now you can build something fun that you couldn't do before you bought a lathe. I hope you'll give this a try. Thanks so much for watching. Thanks to my patrons for making all of this possible, and I will see you next time.